Okay, welcome to not calculus, chemistry. I'm picking up this valence electrons quiz. If you recall, we just looked at the octet rule that 8 electrons, with some exceptions, helium and hydrogen and so on. Now, right now, I want to talk about this. Give the Lewis diagrams for the following neutral atoms. That means you need to know the valence electrons real quickly. Find carbon on the periodic table. It's in column 14. Just so happens if you take off the 10, like subtract 10, 14, that's 4 electrons. Carbon has 4 valence electrons. 1, 2, 3, 4. Anything underneath carbon, silicon, for example, has 4 valence electrons in that column. Nitrogen is at the top of the 15th column. 5 valence electrons, 15 minus 10. Phosphorus and arsenic also would have 5 valence electrons. They're in the same family. So 1, 2, 3, 4, 5. Oxygen in the 16th family. Sulfur is also in there. 6 valence electrons, 16 minus 10. Looking at the top of the column for the number. 4, double them up then, 5, 6. So 2 loners, 2 pairs. Neon is in the 18th column. Noble gas, it's completely filled. 8 valence electrons. 18th column, 18 minus 10. So I can double everything up right away. I know it's all going to be filled. Now, I left this out. Give the Lewis diagram for any group 17 element. It doesn't matter if I'm talking about fluorine, chlorine, bromine, iodine, or aspartame. Not that you'll use it. I'll just put an X there like a variable. Anything in that 17th group will have 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. You'll notice they have 3 pairs and 1 loner. That 1 loner is going to want to form. Now, give yourself a moment. Pause the video, copy out this covalent bonds. Okay, I'm assuming you've started the video because you have this. I'll read through it. Covalent bonds are formed between 2 nonmetals that are sharing electrons. Molecules have covalent bonds. Molecules are compounds made up of non-metals. Typically in our class, by the way, if you have a metal and a non-metal, that'll be an ionic compound, different type of bond. So covalent bonding can cooperate, sharing electrons. Now, Lewis diagrams and molecules. Having green here, a line represents a bond between 2 electrons. And we're going to use the example of water, H2O. Now, if you look at the ingredients of water, H, and O, separately, the Lewis diagram for hydrogen is 1 dot, hydrogen, 1 dot, and oxygen, 6 valence electrons. Just done that for oxygen. Now, what's important is that oxygen has 2 spots with loners. Those are where the bonds are. Hydrogen, because it's from the first row, only wants 1 additional to make a pair. So this works perfectly. That's what you're thinking there. So this works. Good. So what I do is, I think, oxygen I have, I'm going to just do the molecule over here. 1, 2, 3, 4. It wants to bond up there with the loners. So I'm going to take the single dot from the oxygen and the single dot from the single electron from the hydrogen and use the line to represent the bond shared between 2 electrons. This is the 1 electron from The oxygen bonding with the one electron of the hydrogen. Now, likewise, it'll be the same thing again. This line represents two shared electrons, the covalent bond. So just think of it as like this one to that one, this one to that one. That's how this works. I'm going to get you guys to do some practice. And it's kind of trial and error to see how they fit together. Ignore the 3D thing right now, because I'll have to give you a chance to play around with models. But draw the molecular structures. Draw them at least one atom of each alone, and then just see how they fit together, okay? The hydrogen, each is a single dot. We just did that. Hey, look, they both want one bond. They can make each other happy. Give that a shot. Pause the video and then prepare with me. Okay, I'm assuming you've tried this. You can put them, even though the dots are on the top of the H's, you can put the bond sideways. That's just fine. A nitrogen, 5 valence electrons. 1, 2, 3, 4, 5. You notice it has 5 singles? That's the spots where the bonds are going to happen. And we just so happen to have H3, 3 H's that want to bond with it. They all want singles. Give it a try. Pause the video. Okay, I'm assuming you've tried it. The lone pair does not bond. Again, these are the sites where the shared electrons are going to happen. Now, H2O2, hydrogen peroxide, oxygen, again. Now here's the weird thing. If it's just H2O, it's water, but you've got 2 O's. Something's got to be a little different than the water because you'll plug up all the oxygen. Think about this. Play around with it for a minute and then continue with the video and compare with it. Okay. Oxygen might arrive at the conclusion that the oxygens need to bond with each other at least once. It's okay, by the way, to give the mirror image with the dots on the pair of dots on the left side. You join these together, each oxygen still has a spot where it wants to be bonded. That's where the H's would go. Okay? Lastly, OF2. Try that out. Keeping in mind that F, fluorine, is a halide. It's in the 17th column, 7 valence electrons. It'll have 1 single. Hint, it's going to be something like water. Try it. Okay. That's what OF2 would look like. I'm going to open up my door. I'm expecting some students. Okay. I say here, build these with a model kit and draw this 3D structure. We'll try to get some time to do that in class. Now, double bonds and triple bonds. I'll give you examples here. The simplest examples are oxygen and nitrogen. So far, we've shown triple bonds. But what about an oxygen with another oxygen? I'm going to draw it like this, individual. And think about this. This single and this single. This single and this single. They can make each other happy. What I would do is draw out oxygen, oxygen, but show the double bond right in the middle. 1, 2. Then the leftover civil electrons, space them out even if you can. 1, 2, 3, 4. My board isn't responding. 1, 2, 3, 4. That's a double bond. Those two bonds represent 2, 4. 4 electrons shared covalent. Nitrogen, 5 valence electrons. I'll make that dot. Now, think, there's one nitrogen and another nitrogen. Each one triple or 3 bonds, so they got to help each other out. So I'm going to put the nitrogen, the triple bond in the middle, 1, 2, 3. Then what's left over is a couple of dots. Now, I put them on the side. You put them on top of the end, that's okay. It's not. That's what the nitrogen, the triple bond. Now, I want you to try this with carbon and hydrogen and oxygen for CO2. It's going to involve some double or triple bonds. Pause the video, try them out, and then we'll compare it. Okay. I'll take a look at them right now. Okay. I'm assuming you get it. Carbon tends to be in the middle. Hydrogens are always on the ends because they carry us. Two. If I put a double bond, try that first. That means, oh, by the way, carbon, 1, 2, 3, 4. Carbon can bond 4 times is what I was thinking. Well, with this carbon here, it's already gotten 2 of the 4 bonds at once. So it has 2 remaining. Let's see if we can make this happen. Now that carbon on the left has 4 bonds. We're going to hitch them up to hydrogens. Likewise, the mirror image on the right. Now, C2H2, almost the same formula for B. But fewer hydrogens to hitch up, so I suspect this is a triple bond. 1, 2, 3. See if that works. That carbon has 3 bonds already. It wants a 4th. So I'm going to toss it in for the hydrogen. Likewise on the opposite. CO2. This gives people some grief, so I'm going to just show you what I'm thinking. Carbon with 4 bonds wanted. Oxygen wants 2 bonds. So I'm going to go left and right. Double bond, double bond. That takes care of the carbon's 4 bonds. Oxygen wants 2 bonds. They'll have 2 pairs left over. There you go. I'm going to ask you to try a few more. Don't worry about the 3D right now, just the what we call Lewis. Pause the video, try these out. Resume when you want to check over your answers. Okay, I'm assuming you tried this. Keep it in mind, CH4, 4 bonds for carbons. 4 singles, we'll bond 4 times. 1, 2, 3, 4. H, 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 H. That's what your methane, CH4, looks like. NH2Cl. Play around with this one. The H's only want 1 bond, the Cl only wants 1 bond, so your N should be the same. Nitrogen, drawn it before. 1 pair, and it wants 3 singles, so it wants 3 bonds. So it doesn't matter if you put your Cl on the left, the right, or the bottom. I'm going to put it right. It has all these leftover pairs. And then the H's. Should look something like that. Now, H2S. S, sulfur, is in the same family as oxygen, the 16th column. So this is actually going to look very much like water. Elements in the same family, same column, form similar compounds. Now HCN, this one's kind of weird for some carbon in this. You can play around with it and see and hopefully arrive at this. I'm going to put a triple bond to the nitrogen. Carbon still needs an additional bond, and good, we have a hydrogen to take up that spot. Last thing is Lewis structures of polyatomic ions. Let's see here. Take a moment, pause, and jot these things down. We'll work them out together. Okay, I'm assuming you've jotted this down, you've resumed the video. Draw the structure of the following polyatomic ions. Those are the ones in the middle of your ion sheet. Ammonium, NH4, with a plus sign. What does that plus sign mean? It means one electron is missing. So, I'm going to draw the elements single first. 3, 4, 5. And hydrogen 4 times. I'm not going to draw 4. Now think of this. You have one electron missing. I would suspect that the nitrogen is in the middle because it can bond many times, hydrogen can't. So I'm going to take one of these electrons, oh, there we go. One of these electrons away. I got to erase my missing electron in this. There we go. Now, I have one electron missing, and guess what? N can bond 4 times because that's 4 singles. I'm going to draw that. N, 1, 2, 3, 4. H, 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 H. I'm going to move that electron that I moved out so it doesn't look like it's out of the diagram. Now there's NH4, but I have to indicate that there's something different about this diagram. It's missing the electron, so I'm going to put the bracket around this, a square bracket with a plus sign. That's what that indicates. One electron missing from what you regularly imagine. How about cyanide? Something exciting. That one extra electron when you have a negative. I'm going to put that extra electron here for a moment. We'll see. So normally, C, 1, 2, 3, 4, N, 1, 2, 3, 4, 5. I just have to memorize. We've got an extra electron. Now, nitrogen wants 3 bonds, carbon wants 4. With that extra electron, if we plugged up one of the carbon spots, that's what I'm suspecting, it would work better. So let's put this in here. Carbon, nitrogen, triple bond. Nitrogen already has the 2 pairs. We have a single here, but I'm going to take that extra electron, put it on the diagram. Guess what? Everything is associated with 8 electrons. For the nitrogen, there's a triple bond. So 6 electrons involved, shared with that triple bond, plus the 2 here. That's 8. Same with the carbon. 6 electrons involved, shared with the nitrogen, the triple bond, plus the 2 lone electrons. Pair. That's 8. We have to indicate that we added an extra electron because the square bracket minus. That's things with charges. The last thing is, pause the video and write down isomers. I'm assuming you paused and written this down. Sometimes a chemical formula without a name can result in more than one structure. When a formula has more than one possible structure, we call the structures isomers. So I don't do it without you guys. We've got it down in the example. Draw 2 possible isomers for C3H4. One has a triple bond, the other has 2 double. You have it already. Try this out. Pause the video. Resume when you've got something that you're truly studying. Okay? I'm assuming you've done this. Okay. How about this? C3H4. So C, C, C. We could try the triple bond. Let's go 1, 2, 3. That leaves one spot extra for a hydrogen. This carbon in the middle has to also be bonded to the other carbon. Guess what? There's no space for any hydrogens to attach to that. It has the 4 bonds. 8 electrons shared. So this guy on the right needs 3 additional bonds. 1, 2, 3. Hydrogen, hydrogen, hydrogen. There we go. You might have had the mirror image of that, or you might have worked it up and down instead of left. What is triple bond? Okay, that looks like that one. How about 2 double bonds? That's possible. 1, 2, 3 for the carbon. Double, double. Now on the left, that carbon has 2 spaces for hydrogen. The middle one has 4 bonds already, so 8 electrons. The octet is satisfied. On the right, mirror image of the other end. Okay. You now have the tools to try. We haven't started already. Questions 1 through 4 on the hand-in assignment. Get cracking on that with Lewis diagrams. Check in with me tomorrow if you